Hello everyone, as a part of solving top 150 lead code problems, this is the second problem which we will be solving it in this video, which is similar to the two sum problem which we have solved the first question, but it is with a different flavor. Let's go through the question. Given an one indexed array, it's not zero index, it is one indexed array of integers numbers that is already sorted in non-decreasing order. This is good information here. Find two numbers such that they add up to a specific target number. Let these two numbers be numbers at index 1 and numbers at index 2, where index 1 is less than index 2 and it is less than numbers length. Fair enough. Then return the indices of the numbers index 1 and index 2 added by 1 as an integer array index 1 comma index 2 of length 2. Okay, the tests are generated with that there is exactly one solution, so there is no possibility of two solutions in a single array. You may not use the same element twice. Your solution must use only constant extra space. So if you have observed in the last two sum problems, there we have used a dictionary or a hash map to save a index and the number itself in a extra space. That we need not to do that in this question. That is the constant here. Plus we also know that since this question or the array of integers is in the non-decreasing order, the first thing which comes to our mind is to use two pointer, and that will be the optimum solution here rather than iterating with O of n or saving it in the dictionary. Yeah, so with the two pointer approach, what we are going to do is we are going to initialize the two pointers, left pointer and a right pointer, and keep adding the sum. For example, let me pull out this example here. 2 7 11 15. Yeah, so if you see, the example is 2 7 11 15, which is similar to the two sum example what we had, but in this case the constant is the array is sorted, so it will be good for us to use the two pointer. So what we are going to do is initialize two pointer. So basically what we do in the two pointers, like initialize two pointers, one on the left, call it a left pointer, and one on the right, call it a right pointer, and we are going to find the sum of these so that it meets the target. So what I'm going to do is a sum equal to, let's say the pointer is at 0 and this is at 3. Now what we are going to do, n of 0 plus n of 3, that is nothing but 2 plus 15, that will turn out around 17, and our target in this question is 9. So our target is 9. So 17, as you can see, is greater. We can safely move the right pointer pointing here. We can decrease the pointer here because sum is greater than the target. If it was otherwise, we would have moved a left pointer here so that the sum would be greater than the target. Yeah, so if we move here, so now sum will be 2 plus 11, which is 13, again is greater than 9, greater than 9. So again we will move a pointer here. Now right pointer is at 1 and left pointer is at 0 still. So now we will do 2 plus 7 is equal to 9, and this will meet the target, and we will return, since we need a 1 based index, we will return L plus 1 comma R plus 1. That will be the solution. Yeah, same can be applied for the second example. Let's try to solve it here itself. So if you see, the target is 6. Here we will initialize one pointer, here we will initialize another pointer. So here it is R and here it is L. So we say R plus L is this plus this is equal to 6. So 0th index plus second index here. So we will return 1 comma 3. So that's what it is. Yeah, let's implement it in C# quickly. Yeah, so we need to have two pointers here, and right, which is equal to numbers dot length minus 1. Pardon me for the spelling. Yeah, and then and left equal to 0. So these will be two pointers, one pointing to the left and other one pointing to the right. Then I will have a while loop where I'll say left should be greater than right. Since we can't use the same element twice, so there is no need of doing a equal to sign there. Yeah, and then we need to find a sum, like int sum equal to numbers of left plus numbers on the right, and then check this sum. If sum is greater than the target which we are finding, if it is greater, then we need to shift our right to else if sum is less than target. If sum is less than the target, then I need to increase the left. If it is not greater, if it is not smaller, that means we got the solution which is matching. So I'll just say return new int array with a increased index, that is left plus 1 comma right plus 1. Otherwise I will return null. Yeah, let me quickly run and check if there are any syntax errors here. Since left will never be greater than right, we will not be able to get into it. So okay, let me correct the condition here. Yep. Yeah, so let me submit quickly. As you can see, it is beating 100%. This is the fastest solution with the two pointers. Thank you for your time. See you in the next video.